Hello all, welcome back. This is the fourth lecture of Module 2 of Transportation Engineering 2. So, in this lesson, we will be discussing about coning of wheels. The theory of the flanges of wheels is never made flat, but they are in the shape of cone with a slope of 1 in 20. The coning of wheels is mainly done to maintain the vehicle in the central position with respect to the track. Coming to the definition of coning of wheels. The wheels of railway vehicles against general belief not flat but sloped. Usually beveled by means of a cone semi-angle of the arrangement of 1 by 20 radians. This is to make the train run at the center of the railway track and to turn without slipping off its track. Since the wheels forms a part of cone, hence called coning of wheels. We will discuss here in detail why coning is provided and its benefits. Before that, we can discuss what is the concept behind coning of wheels. Consider a cone. I will draw a diagram of a cone here. So this will be the larger diameter and this is the smaller diameter. Consider a cone as shown in figure. Guess what happens when it is rolled? The answer is simple. It rolls in a circular path. The reason is that for one complete rotation of the cone, the distance covered by the two ends is different. The end with larger radius covers longer distance and end with lower radius covers the smaller distance, which leads to the above said rolling in a circular path. But how is this simple concept useful in railways? Come on, let's discuss about how it helps in the railways. Need for coning of wheels. Railway wheels sit on the rails without guidance except for the shape of the tire in the relation to the rail head. So, usually large curves are avoided to reduce wear and tear and accidents. The smooth flow of train on the tracks is made possible by coning of wheels and providing cans. Contrary to the popular belief, the flanges should not touch the rails. Flanges are shown in figure are only a last resort to prevent the wheels becoming derailed. They are a safety feature. But the continuous contact of flanges with the railway track causes large wear and tear and inconvenience to the passengers. So the wheels should be kept central without any contact with the flanges. You can see the details in this figure. Here you can see the rails. Rails are away from the flanges. So these portions are termed as the flanges. And the rails are centrally placed, right? Wheels are centrally placed. They are not contacting with the flanges. If they come in contact with the flanges, wear and tear will happen. So that should be avoided, and the flanges are provided only as a safety feature. Now let's see how coning maintains the wheel at the center of the track. Take the case of a straight track. For smooth riding, the tracks should not touch the flanges, for the track should touch the center of the wheel. Coning makes sure that the track always touches the wheel at the center. When the wheel deviates from the center of the track, as shown in figure, coning of the rails retains them to the center. Notice that the portion in contact with the wheel is the larger diameter and the right wheel touches the rails at the smaller diameter. Now, the right side wheel threads small distance and left wheel threads large distance. As a result, the whole wheel set system slightly shifts to the right, making the wheel remain at the center. This process is continued and in effect, the wheel always remains at the center. Now consider a train taking a right curve as shown in figure. Here the train is taking a right hand curve. You can see that the left wheel flange touches the railway track. Now the train has to be made central without any other extra mechanism. Now the concept we studied above comes into play. Notice that in the inner rail the smaller diameter of the cone of wheel is in contact with the rail, while the larger diameter of the outside wheel is in contact with the rail. When the above scenario is exaggerated for more understanding, it looks something like this figure. Now, the inner wheel travels less for same rotation relative to the outer wheel. In effect, the train turns to right. The flange of the outer wheel will only touch the movement of train around the curved rails, is not in exact symmetry with the geometry of the track. This can occur due to incorrect speed or poor mechanical condition of the track or train. It often causes a squealing noise. It naturally causes wear. Hope all these concepts are clear to you from these figures that we used here. This is a simple concept. In a nutshell, we can summarize that the wheel should be in a conical shape. That ensures the safety of the train and it ensures the smooth riding of the train through the railway track. So now we will discuss about the advantages of conical wheels. As discussed from the previous slides, it is clear that it reduces wear and tear of the wheel flanges and the rails. It also provides a possibility of lateral movement of the axle with its wheels. It prevents the wheel from slipping. So, in a nutshell, it is very important that we should provide the shape of the wheels as a conical shape. Now we will discuss about the disadvantages of conical wheels. Pressure on outer rail is more, by inner rail it is less. This causes wear of outer rail. Due to centrifugal force, the horizontal components tends to turn the rail outward and gauge movements. If no base plates are provided under the voids, the sleepers under the edge of the rails are damaged. In order to minimize the above demerits, tilting of rails is done. So in the coming slides, we will discuss about the tilting of rails. Tilting of rails. Tilting of rails is provided to minimize the disadvantages of coning. Here, the rails are tilted inwards. For that, inclined plates are used. Generally, sleepers or base plates are not laid, but a slope 1 in 20 inwards is provided. You can see the details of tilting in the figure. It is otherwise known as adzai of sleepers. Now we will discuss about the advantages of tilting. Tilting helps to maintain the gauge properly. The wear of head of rail is uniform due to tilting of rails. If we provide tilting of rails, we can ensure that there won't be any uneven wear and tear. It increases the life of sleepers as well as the rails. So these are the topics that we plan to discuss on today's lesson. Mainly we focused on coning of wheels and tilting of rails. So you can expect some questions from these parts for the theory portions. So you have to focus these portions before entering into the exam hall. So see you with another lesson that is creep in rails and sleepers. Until then, Bye. Take care.